We've already talked about what the p-value is and how we can find it. And we did so when dealing with a alternative hypothesis that the population proportion was greater than 50%. However, we could have tested different hypotheses. We could have tested our HA being that is less than 50%, or is that it differs from 50%. And depending on what your alternative hypothesis is, would affect what the more extreme values are for our p-value. When doing a hypothesis test, we need to figure out, are we dealing with a one-tailed or two-tailed test? And that is dependent on what your HA is. If we are dealing with an HA that's greater than, I'm going to draw a little distribution here. Right? What we did is we looked for all the area greater than. So I'll mark this as our test statistic, T.S. And a greater than HA would shade all that area greater than. So we'd look at the likelihood of getting that value or greater values. So this would be for an HA that is greater than. Now what that notation is saying is it's saying your population proportion is greater than some assumed value. Right? So pi subscript 0 or pi naught, it's saying, hey, what is your assumed population proportion? If we were dealing with an HA that is less than, well, at our test statistic, we would then find all of the area less than your test statistic. Your p-value would be all of that area. If we have a does not equal to hypothesis, HA differs from some assumed value, then what we do is a little bit tricky. We look at the positive and negative version of our test statistic. We're not going to care if it's positive. We're not going to care if it's negative. We're going to create two versions of it, a positive and a negative version. And we'll find all the area less than the negative and greater than the positive. This is what we call a two-tailed test, where you care about both sides of your graph. We don't care if it's bigger. We don't care if it's smaller. We just care that it's different. So because of that, we're going to look at two sides of our graph. A one-tailed test is if we look at one side of our graph, like we did for greater than and we did for less than. Two-tailed is when we have a does not equal to HA. In our next lecture videos, we're going to check out an example to kind of represent a less than hypothesis and a does not equal to hypotheses. The does not equal to one is probably the more tricky of the bunch, and we'll go a little bit more in depth of why we're doing what we're doing when finding that p-value.